Alright guys, in this second question, I've drawn out this ellipse and we're just going to focus on P, not going to worry about this Q point in this particular part of this question. Okay, so we're actually not going to use anything to do with Q. I'll actually give you a question probably tomorrow where you have to find the coordinates of Q. Okay, but for this particular one, we don't need to worry about that Q point at all. So here's P, and what you're asked to do essentially is you're asked to find this distance. If this is the microwave here, okay, which is perpendicular to the motion, okay, so this tangent line here would represent basically the gradient, okay, at point P, and this line here is where the microwave is going then. And what you're asked to do is to find the vertical distance of where the microwave basically hits this vertical plane, okay, relative to the position of the satellite. So if you think about that, what you're actually after, if I draw in, would be this distance here. So let's say it cuts here. Okay, so we're actually after this distance here. So have a think about how you could get something that's going to tell you that distance. So just give you a moment to think about that. Okay, well this vertical distance here, I'll call it D1, okay, which is all the way from here to here, is made up, we can think of it as being made up of two parts. You could say it's made up of this distance here, which is just the y coordinate value, okay, for point P. So that part there in that dark blue, and then in this light blue we would have also this here. And you could think about that blue distance as equal to this here, which would be the y intercept of this perpendicular line. So you could get that distance, this light blue distance here, if you got the equation of this perpendicular line and found out what was the y-intercept, which is when x equals 0. So there's quite a bit of clues there. So have a pause now and try and get another clue would be an equation of the normal line. Okay. Don't forget, you're also told that P has these coordinates, A sine theta, B cosine theta, but you're also told that theta is equal to pi over 4, which is this angle here. So you should be able to get the coordinates of point P, okay, in terms of A and B, using this pi over 4. Okay, so yeah, have a go, see what you can come up with. Okay, so welcome back. So I'm interested to see what you guys have come up with. But what I'm going to do is I'm going to get the equation of this normal line here and get this y-intercept of that normal line, which will give me this blue distance here. And also I can get this vertical distance basically straight off. How can I do that? Well, I know that point P occurs when this angle is pi over 4. So don't forget this special triangle. God, that's terrible. Let me try and use a couple of lines here. So one line there, another line here, a third one there. Let's use that. So that's pi over 4. And this is 1 root 2. Okay, so the sine of pi over 4 is 1 over root 2. That's also the cosine of pi over 4. It's also 1 over root 2. Okay, so we can get P as A times 1 over root 2, B times 1 over root 2. In other words, A over root 2 and B over root 2, which means that this dark blue distance here is B over root 2. Now, if I can find this light blue distance using the equation of this normal and getting the y-intercept, I can add that this distance here, the blue distance, together with the dark blue one to come up with the answer, which is how far relative to the satellite is the does the microwave, what's this distance here when the microwave hits this vertical plane. Okay, so coming up with the equation of this normal line. Well, what I want to do is I want to use this form of the straight line. I know what y1 and x1 are. I can use this point here again. I just need to get the gradient. So how can I get the gradient? Well, we're told the equation of the ellipse is x squared over a squared plus y squared over b squared equal to 1. And if I want to get the gradient, I can derive this, get the derivative of the tangent, and then get the gradient of the tangent. From that, get the gradient of the normal. So to get the gradient of the tangent, I'll need to derive this. So this should be 2x over a squared plus 2y over b squared times dy over dx using implicit differentiation, and that will equal 0. So making dy the subject, let me just do this in a couple of steps. So I'll move this 2x over a squared to the other side, would become negative, and then dy over dx would equal this. And we're going to divide by that fraction, in other words, multiply by the reciprocal. Going to get a little bit of cancelling going on. So the 2 will cancel. And what have we got? Dy over dx would equal negative b squared x over a squared y. So that's the gradient of the tangent in terms of x and y and a and b. So therefore the gradient of the normal, I'll just use that symbol for normal, would be the negative reciprocal of this, so a squared y over b squared x. Okay, so I'm going to move to another page, and then we're going to substitute into this here. Okay, so moving to a new page. So we've got the gradient of the normal was, what was that again? Let's go back a page. Where are we? Back. A squared y over b squared x. Okay, and we have the coordinates of point P, remember, are a over root 2, b over root 2. So let's get the equation of the normal. Y minus this here equal to the gradient x minus b over root, a, that should be. Now the y-intercept is when x is equal to 0. So we're going to get y minus b over root 2. let me just expand this for a moment. Alright guys, I just paused for a moment because I just realized that this would be a lot easier to work with, this gradient here, if I substitute in the x and y value that we have for this point P. So let me do that. So I'm just going to come back to this after I've done that. So let's get rid of this. Apologies about that. Okay, so if x equals a over root 2 and y equals b over root 2, this gradient would be a squared times b over root 2, that divided by b squared times a over root 2. So it'd be a squared b over root 2 times the reciprocal, which will be root 2 over a b squared, which is going to simplify right down. I'm going to have that cancels with that. We're going to have one of these b's cancelling and one of these a's cancelling. So we're going to end up with a over b. Okay, which is a lot easier to work with. So therefore the equation of the normal would be y minus b over root 2, which is y1, equals this gradient, a over b, x minus a over root 2. Let's expand this out a little bit. So a over bx minus a squared over, let's say, root 2b. And then we want the y-intercept. When x equals 0, so we get y equals, sorry, not equals, minus b over root 2. This becomes 0, so it would equal negative a squared over root 2b. Now that means that y would be equal to, let's move this to the other side, let's write that positive term first then, minus a squared over root 2b. Now if you think about going back to our previous page, if you think about this as a distance below the x-axis, so one way we could write this as negative, because it's down, so that would be a squared over root 2b minus b over root 2. So let's go back to that previous page. So that's this distance here, okay, that I'm just highlighting again. Okay, so this distance here. Okay, so in terms of a negative coordinate, we've got that negative and then that bracket. So this bracket here, okay, is this distance. So I actually want the distance. I don't want to know the direction. The direction is the negative sign. I want that distance here, and then I'm going to add that to this blue distance here, which is b over root 2. So let's go back to that page. So therefore, the total distance is going to be b over root 2, which was that dark blue distance, plus this distance here. And you find that this and this cancel. So we've got a squared over root 2b. Now if you go back to the question, if I can get that question up here, one sec, come here, bring that over. We're asked to show that Okay, we've got root 2a squared over 2b. Now, what did I end up with? Something slightly different. Have I? One sec. A squared. Okay, so they've got root 2a squared over 2b, which is exactly the same as this, because we can write this as 2a squared root 2. Yeah, root 2a squared over 2b, because the root 2 over 2 is equal to root 2 over root 2 squared, which gives 1 over root 2. So these two here, oops, these two here are equivalent. Okay, so we have that expression for the total distance that was asked for. All right, if you need to, ask about this one on Friday if you're still stuck on it. Yeah, and perhaps let me know if you are still stuck on this. Okay, catch you in class, guys.